Okay, these are your notes for sections 6.2 through 6.5 on similarity. And first thing we're going to talk about is what similarity means. Now, similarity, all it really means in basic terms is that things are the same shape, but different sizes. Okay, so they're identical, except one is smaller than the other one. So two things will look exactly the same, have the same shape. They don't necessarily have to have the same orientation. One may be flipped upside down, but they're the same shape, different sizes. And we've got three examples here. This first one, we have squares, a small square, and then a larger square. They're the same shape, just different sizes. So yes, these are similar. Second example, we have equilateral triangles. We have a small equilateral triangle and a larger equilateral triangle. Same shape, different sizes. So yes, those are similar. Here we have what looks like a small rectangle, and then we can tell that this larger rectangle is obviously larger. Okay, it's longer. So no, these aren't similar. Why they may be the same shape, they're both rectangles, they're just not identical. Okay, one is longer, the bigger figure is longer, so it's not exactly the same shape as the smaller one. Okay, and that's what we mean by similar. They have to be the same shape but different sizes. Now, if you want to prove or verify that two figures, two polygons are similar, there's two things you need to do. The first one is that you need to have pairs of congruent angles. And I'm going to say between figures. So that means, all that means is that if I have an angle in the first figure, it needs to pair up and be congruent to an angle in the second figure. And that has to happen for every angle in your figure. So if you have a triangle, you need to have 3 pairs. If you have a square, you need to have 4 pairs. If you have a pentagon, you need to have 5 pairs of congruent angles between the two figures. That's all this first one means. And I didn't even finish my sentence. Pairs of congruent angles. Okay? Pairs of congruent angles. The second thing is that the sides, all sides, are proportional. And what that means is that you'll take the side number 1 of the first figure and put it over side number 1 of the second figure. And then you'll take side number 2 of the first figure and put it over side number 2 of the second figure. And you continue to do this. So this is the first figure, this is the second figure. You will continue to do that, and all of those should be the same fraction. The same ratio, or the same, we could set up that's what it means to be proportional. All of them have the same ratio, okay, the same fraction. We've got an example, and I'm going to walk you through how to test, how to verify that these two figures are similar. The directions say, are these triangles similar? So we know we have triangles. What we need to check for first is whether our angles pair up and are congruent between figures, and then second, we need to check and see if our sides are proportional. Let's start with the angles. We've got 59 degrees here and 35 degrees in this triangle. We need to figure out the third angle. To do that, we would do 59 plus 35. That equals 94. And then 180 minus 94 gives us 86. So there's our third angle, 86. In our second figure, we have two angles. They're not the same two angles. We have 35 and 86. We're going to add those together, and we get 121. And then we have 180 minus 121 gives us 59. So there's our third angle in the second. Now if we look, we have the same three angles in both triangles. We have a 59 degree angle, a 35 degree angle, and an 86 degree angle. So yes, they have the same angles. They pair up. There's one angle of each measure in both triangles. That's what we want to see. Now, proportional sides, we want to take the sides that correspond with each other and make fractions out of them. So let's start with AB. AB corresponds, that's from 59 to 86. So over here we need to go from 59 to 86. That corresponds with DE. And we're going to put values in for those. AB is 6 and DE is 4. Now that reduces down to 3/2. Okay, that's our first fraction. Now what we want to make sure is that the rest of the sides do the same thing. So let's go to BC now. BC corresponds, it goes from 86 to 35, so it corresponds with EF. BC is 9 and EF is 6. If we make a fraction out of those, we get 9/6, which reduces down to 3/2. 3 goes into both 9 and 6. 3 goes into 9 3 times. 3 goes into 6 twice. So far we're doing so good. The first two have the same ratio, the same fraction. We have one more. We're going to go from C to A, which corresponds from F to D. So C to A over F to D equals, C to A is 10.5 over F to D is 7. Now that one's a little different because we have a decimal in, so we're going to put that in the calculator, and we end up getting 1.5, and we're going to make that into a fraction, which is 3/2. So yes, the sides are proportional. All of them ended up with the same ratio, the same fraction. Okay, and that's what you want to check for. So if 1 and 2, we have circled here, if our angles all pair up and are congruent, and our sides are proportional, if both of those are yes, then yes, the two figures are similar. Now when they're similar, we can add two things to our answer. We can give the scale factor. And the scale factor is just that ratio of the sides. It's part of your answer when you determine that they're or if they're proportional or not. It's right here. It's this 3/2. So it's 3 to 2. That would be our ratio, or our scale factor, 3 to 2. And you could write it, instead of writing it like that, 3 to 2, you could say 3 over 2. It's the same thing. So it's part of the work that you've already done. It's not doing anything new to the problem. It's part of the work you've already done. Now, a similarity statement is like a congruence statement. The difference is you use this symbol. Okay, it's called the tilde. And what we do is we write it out. Triangle ABC is similar to triangle DEF. And that's our similarity statement. Okay? It's the same idea as a congruent statement, but we use a different symbol, which means similar instead of congruent. Because remember, similar are different sizes. Congruent means they're exactly the same size. Similar means they're different sizes. So we have to use a different symbol. But we write it just like we would a congruent statement. All right, we've got one more example here. This example says the two polygons are similar. And we need to do the following 4 things. First, we need to write a similarity statement. Second, we need to calculate the value of x. 3, we need to determine the measure of the missing side. And 4, we need to give the scale factor. And we're going to walk through these 4 things. This is more typical of what you'll see on your homework. You'll have to do these 4 things for a problem, okay? Now, we already know they're similar, so we do not need to go through and check. We don't need to check angles. We don't need to check sides. We can go ahead and jump right in and write a similarity statement. So we're going to start here at L, and I'm going to pick one way around my first figure. I went from L, M, N, and O. We don't know the name of that. I'm sure most of you do. You can tell me what shape it is, but it doesn't tell us specifically what it is. So we're just going to say polygon L, M, N, O is similar to polygon. We have to do this one in the same way. So we're going to go from J to K to H to I. Polygon J, K, H, I. And there's our similarity statement. Pretty simple. All you need to do is make sure that the things match up. You're starting at the same angle in both and you're going the same direction around the figure. Number 2 now. We've done number 1. Number 2, calculate the value of x. To do that, we're going to use a proportion. We're going to set up a proportion between sides, and we're going to figure out the value of x. Notice that our x is here. So that's going to be the first thing we write down. X over, and we want it to correspond to whatever side in the other figure, which ends up being 13, equals, and now I can pick anything else, any other two sides that have that have numbers on them. I'm going to pick 13. Notice I went back to my first figure, my small figure. All right, small over the large. That's how we're going to set this up. So anything from the small polygon goes on the numerator, and anything from the large polygon goes in the denominator. 13 pairs up with 26. So we have 13 over 26. And again, small figure values are on the top in the numerator, large figure values are in the denominator. And now we solve. We cross multiply. We get 13 times 13, which is 169, equals the other two, 26 times x is 26x. Going to divide both sides by 26. So x ends up being 6.5. Alright, so there's the answer to our problem. Now, that's if we have one side that's a variable. If you have more than one side that's a variable or has variables in its expression, that's fine. You can use them in your proportion. You just need to make sure that whatever you're pairing up, notice again how I put the small on top. Small is always in the numerator, and the larger figure is always in the denominator. That's how we need to set these up. Alright, so there's number 2. We've calculated the value of x. Number 3 says determine the value of the missing side. Determine the measure of the missing side. So what we would do is plug in x to figure that out. Well, hi here equals x, so hi ends up being 6.5. That one's pretty simple because all we have to do is plug in x. X is what we found. So whatever value we found for our variable, you need to make sure you plug it back into the problem to figure out the missing side. If you have two missing sides, you need to do it twice. Okay? But always plug it back into the missing side. And the last step here is to give the scale factor. Remember, the scale factor is the ratio of sides. Now, we've already done this. It's in our proportion. We did it right here. Okay? So 13 over 26, that's going to reduce now to 1/2. So there's our scale factor. Scale factor is 1/2. You could write it 1 to 2. That's perfectly fine. But do not leave it as 13 to 26 because that's going to reduce. Now that's everything we need to do on this example. Again, we've written our similarity statement. Number 1, remember to start at the same angle and work your way around. Number 2, calculate the value of x, the value of our variable. We use a proportion to do that. 3, determine the value of the missing side. We plug whatever we got for x back into the problem, into the expression to get the value. And then 4, give the scale factor. Well, we did that in our proportion. We just need to simplify that fraction, simplify that ratio, and we ended up getting 1/2. So that's how we would do a problem like this. If you have any questions, rewatch the video, specifically this example, because this is more of what you'll do on your homework. If you still have questions, then bring them to class next time.